All right, today we're going to dive into a really exciting frontier in artificial intelligence. It's an approach that promises to solve one of AI's biggest, most fundamental problems, its total lack of common sense. Let's get into it and see how NeuroSymbolic AI is completely changing the game.
So let's start with a question that gets right to the heart of the matter. You know how your phone can instantly pull up every single picture of a cat you've ever taken? It's incredible at pattern recognition. But here's the catch. If you were to ask that same AI why it knows something is a cat, it's got nothing. It can't tell you. It doesn't actually understand what a cat is. It just recognizes pixels it's seen before.
And this, right here, is what we call the infamous black box problem. Modern AI can see, but it doesn't truly comprehend. It's a master pattern matcher, but it just can't reason about what it's seeing. This is exactly why a simple cartoon drawing, or even just an upside-down photo of a cat, can completely throw the whole system for a loop. It's the core reason AI lacks what we would call genuine common sense.
I love this quote from our source material because it just sums it up perfectly. Today's AI is that student who has memorized the entire textbook. It can ace the test through brute force repetition, but the moment you give it a new problem it's never seen before, it can't think for itself. So how do we build an AI that doesn't just see, but actually understands?
Well, to understand how we get to an AI that can actually think, we first need to look at the two big historical paths that got us here. For decades, the entire field of AI was basically split down the middle into two completely different competing camps, the logicians and the learners.
So on one side, you had symbolic AI, which we can call the logician. It's all built on very explicit, human-written rules and logic. The great thing is, it's totally transparent. You can see exactly why it made a decision. But it's super rigid. And on the other side, you've got neural AI, the intuitive. This is what we have now. It learns patterns from just massive amounts of data. It's incredibly flexible and powerful, but its decision-making process is a complete black box.
This is a perfect way to picture the weakness of pure logic. Think of symbolic AI like a botanist with a very strict checklist. Rule number 1, a plant must have leaves. Rule number 2, a plant must have a stem. But what happens when you show it a cactus? It checks its list, sees no leaves, and the whole system just breaks. It's logical, for sure, but it just can't handle the messy, beautiful chaos of the real world.
And then, of course, came neural AI. It learned by looking at millions of pictures of plants. It doesn't need a checklist, it just knows the pattern. But here's its own fatal flaw. If you show it a really convincing plastic plant, it'll confidently tell you, yep, that's a plant. Why? Because it's only learned what a plant looks like, not what a plant is. It recognizes the pattern, but it can't reason about the meaning.
So we've got these two very different approaches to AI. Each one is powerful in its own way, but each one has a critical, deal-breaking flaw. So the question becomes, what if we could combine the strengths of both? Well, that is exactly what the neurosymbolic solution is all about.
Okay, so here's the key takeaway. NeuroSymbolic AI is a hybrid. It truly takes the best of both worlds. The neural part, well, that comes from the neural networks. That's the powerful learning and pattern recognition engine. And the symbolic part, that comes from classic logic, the structured rule-based reasoning engine. You put them together, and you get a system that can both recognize and reason.
So, how does it all work? It's actually this really elegant three-step process. First, the neural network does what it does best. It perceives the world. It identifies all the shapes, colors, and features in an image. Then, and this is the magic part, it hands that information over to the symbolic engine, which applies logic. It might use a knowledge graph to understand concepts, like a cat is a type of mammal, and a mammal is a type of animal. And finally, the system makes a decision that it can actually explain, because it followed a clear, logical path to get there.
Okay, so that's the theory, and it sounds fantastic, right? But how does a hybrid system like this actually perform out in the messy, unpredictable real world? Let's look at a couple of really brilliant examples.
Let's take the stop sign test. A normal neural network, it might get really confused if a stop sign has a sticker on it or maybe the lighting is bad. But a neurosymbolic system perceives the key features. It sees the color red, it sees that octagonal shape. Then its logic engine kicks in and applies a simple rule. If it's red and it's octagonal, it's a stop sign. It understands why it's a stop sign, which makes it so much more robust.
And this is where things get really exciting. We're talking about something called meta-learning now, which is the ability for an AI to learn how to reason. A neurosymbolic system can actually update its own internal logic.
So it can learn that a whale is a mammal, even though it breaks the has fur rule, because it can reason about other features, like gives live birth and has lungs. This ability to adapt its own rules, that is a monumental leap forward for AI.
So this ability to reason, to explain itself, is what makes NeuroSymbolic AI so incredibly powerful. It's not just some cool technical feature, it is the absolute key to us being able to build trust in AI, especially when the stakes are really high.
Just think about the possibilities here. In science, a NeuroSymbolic AI could reason through incredibly complex molecular properties to help discover new life-saving drugs. In finance, it could flag a transaction not just because it looks like a weird pattern, but because it violates a specific banking rule and can tell you which one. It provides a step-by-step audit trail of its logic, which is absolutely critical in these fields.
So this all really boils down to 4 huge benefits. First, you get trust, because the decisions are transparent and you can audit them. Second, you get robustness, because the system can handle weird edge cases and new situations. Third, you get efficiency, because it can learn new rules with way fewer examples. And finally, you get governance, because it provides a clear logical trail for oversight.
And this brings us to a really vital perspective from the source material. This kind of technology, it isn't designed to make humans obsolete. It's about creating AI systems that can augment our own decision-making. They're tools that can explain their thinking so that we can work together to solve incredibly complex problems. It's about combining machine-scale learning with human-level reasoning. So, as we wrap this up, I want to leave you with this one thought. For the very first time, we are right on the verge of creating AI that can truly show its work. An AI that can reason, that can explain itself, and that can be held accountable. The question is no longer just what can AI do, but now with this newfound transparency, what are the most important problems that we should ask it to help us solve? Stay curious.